Howdy tubers, welcome back to the Zach Live. So this is going to be some work on the generator. I'm having a problem. I don't want to bore you too much with the intro. My intros are always too long. If you'll remember, or if you hadn't watched, originally I built my generator with a cam driven centrifugal blower that blew air through a radiator, and through my mistake it basically wouldn't move enough air at idle and the thing would get hot at idle. To remedy this, I moved the radiator down on the side of the actual body of the coach and put a couple of high-powered electric fans. Now everything in my coach is 24 volts. You can't really get 24 volt electric fans, and so what I did was wired two 12 volt fans in series and ran 24 volts across them. There's no reason this shouldn't work. It should have been fine. It was fine for a while. The other day, about a week ago, it was 108 degrees. And I cranked the generator up just to let it run under a pretty good load, all three air conditioners and what, during a really high ambient temperature, to make sure I wouldn't have any kind of overheating problems. And it seemed fine. It ran for about an hour. It got up to about 190 degrees, something like that, right where we wanted it. And shortly thereafter, I heard it actually shut down. I went back to the look, and it had overheated. It got to about 230, and the computer had shut the generator down. Well, anyway, more or less what happened is one of these electric fans got something up in it. I never did find it, but you could tell it sort of had grooves cut in the fan, between the fan and the housing, and for one reason or another locked up because it got a rock or something in it or was hard to turn. And what this caused was, since it was no longer turning, it had a lower resistance, a lower electrical resistance. And it caused more current to be pushed, or actually more specifically, it caused a higher voltage across the other fan. Of course, that caused probably caused it to run a lot faster, caused a higher current, and it blew a 50 amp fuse. These usually pull about 30 amps anyway. I had it on a 50 amp fuse. It blew the 50 amp fuse, pulled the motors the motors out of the old fans, and they were completely smoked, burnt both of them up. Now this sucks because they were a $300 set of fans, but nonetheless I got a new set of fans, and what I'm going to do, basically I'm going to take an impedanceal alternator, drive it off a cam pulley that we've got a little bit of work to do, and then I'm going to have it produce 12 volts without a battery. It's going to be excited off the 24 volt system, but the only thing this alternator is going to do is to drive both those fans at 12 volts. This way they can each have their own fuse, and if by chance one of them gets something in it and locks up, it'll simply blow that fuse instead of trying to burn the other motor up. Now this probably could have been avoided if I would have put something like a 35 amp fuse in the fuse holder instead of a 50 or maybe a 40 amp or something. But hindsight's 20/20, and I didn't want to fuse it that close. I never dreamed this would be a problem. Anyway, the very first thing I got to do, I've already done some machining, but the pulley that goes on my alternator is not the one that's designed to go on it, and I had to bore it out, but the groove's not wide enough. It takes a really narrow belt. It must be for some unusual, maybe a lawn tractor or something, alternator pulley. Got to run in the machine shop, machine it out, then we'll come back here, and we'll get to work on it. Alright, here we are up here. I got this little pulley all chucked up. So the problem is it's not wide enough effectively for a standard A-size belt. And I'd like to make it wider, and of course by making it wider the belt will run deeper, and so it'll be effectively a smaller pulley. So these are, I believe, about a 32-degree angle, which means each side is 16 or whatever that comes out to be, yeah, 16 degrees. They're between about 32 and 35 degrees, depending on who makes them and what you read as far as being the best. But anyway, 16 or 17 degrees or so per side. So what I'm going to do, and pardon my machine here, it's quite a mess. So this is called a compound, and you can turn this. I've taken these nuts loose. There's a set of marks down here. So there's a mark on this piece. It's right here. I need a pointer. That is right there. You line this mark up with the marks that are on the compound, and this will tell you your degrees. I don't know if you can see it, but that's 10, that's 15, that's 16. Let's go about 16 and a half degrees, something like that. Dang it, there went my phone in the bottom. And then I'll tighten these back up. All right, I'm not sure how well this will work. I may have to do something else, but I've got this as a parting tool. It's made to, you go straining it and you can cut something off. This may flex too much, but instead of grinding a high-speed tool, we're going to try to get away with this. We don't need to move much material. We will we'll just move the carriage, you know, back this way, each cut just a little bit to take a little bit more material, and then we'll run it in and out with the compound here. This is not going to give the best finish, but I think that it'll be just good enough. You know, you can see the tool move there, and that's what, you know, is the problem. We're just going to cut really, really slow. I believe that's it. Alright, sorry about my messy workbench. I'm fixing to assemble the device here that's going to drive this alternator. So this bolts on the bell housing back where one of the camshafts are, and this splines into, golly, a internal spline that bolts onto the back of the camshaft. This will all make a lot of sense in a minute. Just kind of follow me along here. But anyway, I took this apart last week and got a new seal, drove a new seal in it, and this basically just goes in here in that bearing. Pretty straightforward. This is a wear ring. The wear ring is pretty worn, but I think it'll be okay. But what I am going to do is I want to put some silicone. Where did my silicone go? On this shaft here in a couple of spots, because if this thing doesn't seal on a face or on a shaft or something somehow, it's going to leak back by it, and we don't want that. Something just like that. And so that should pop right down against that seal. And when this is tight, this will spin, yeah, just like that. I already see a problem here. I probably need to drive this seal in just a little bit farther. Just like that. That way that seal is more towards the middle of that. Anyway, we've got a half moon key that I've lost. Now this pulley started off 7/8 and I bored it out. This is actually 25mm here, and so I'm not for sure this key may be too proud, and then I cut the edge of it off just so it'll all line up. We may have to grind on that keyway just a little bit. It may be too tall. I believe that's it. There it is. The bearing looked very good, I should have said. I just took this apart. It didn't have a shiv on it, and the seal looked pretty rough. So I disassembled it, put a seal, and of course bought that. Okay, so here we are. Here's the cam cover we'll be pulling off. I got the air filter out of the way so we can sit better. Let me see if I can clamp you on something here. I believe that this has still got the cam drive deal in it because this is where the blower thing I made was driven from. Alright, so here's a little drive thing I was talking about. This thing in the center here is actually drive a tachometer. You can get a tack that goes in here. I think, I don't know, we may have to take and knock it out of there. It may hit right there. One way or another, it doesn't seem to. Yeah, let's bust it off and see what happens. So here's the alternator that I'm going to be using. It's got to be mounted this way. The direction of rotation doesn't matter as far as power output, but the fan is designed to run one way. Anyway, the camshaft turns the opposite direction at the same speed as the crank, but the other way, and so I've got to mount this backwards to turn it the right way. Anyway, I'm not going to video this because it's going to be a bunch of kind of guessing and hunting and pecking here, but basically it's going to just go about right there. I'm going to build some brackets and I'll catch you back when I get the brackets done. Alright, so I got the alternator, the brackets made, the alternator bolted on, the belt on and everything. To continue this video from here on, I need to talk a little bit about the theory of operation of an alternator and kind of some of my ideas behind what's going on here. It's a little bit more complicated, a little bit more in the back of my mind than probably what meets the eye here. So an alternator has got three main parts. Now there's a lot of other pieces that make these three parts operate, but it's got three main components. And that is the rotor. The rotor is a part that spins in the middle. It's got a coil of wire in it, and when you pull current through that coil of wire, like about 4, 5, or 6 amps, we'll see in a minute, it makes that thing an electromagnet. The next part is the stator. The stator is the stationary piece. It's in the case, and it is a three-phase wound set of windings. And this is what actually generates the electrical power. The next is a set of diodes, or set of rectifiers. And so this three-phase stator goes into, is hooked, 3 wires come out of, is hooked to a set of diodes, and the diodes work like a check valve. Now I should have got like a dry erase board to draw this out or something, but an AC wave, you know, is a sine wave like this. And so if you can imagine, you know, if you've got a line here of 0 volts, you know, the voltage of that sine wave goes, you know, down to 12 or 20 or whatever volts, up to 20, down to 20, whatever. Now, also, if you imagine on this graph, you've got 0 volts and you've got 12 or 13 volts or whatever your battery voltage is. You've got 2, you know, 0 and 13. Now, what happens here is called arresting a voltage. And you'll have a sine wave. The sine wave starts at 0, this is the output of the stator, goes down to whatever voltage, up to 0, up to 13, and then the diode, if you would, the check valve, opens and arrests the voltage. So instead of having a wave, it comes up, goes over. This is the part that's arrested and back down to 0. Does that make sense? Now, the voltage output of this wave determines the current output of the alternator. So the higher the voltage, the more you stretch the wave out, the more of that wave, the longer length of time is arrested by the battery and the diodes. If you have, you know, if your alternator doesn't need much output, the voltage will just barely come up and touch that 13 or 14 volts where it's arrested. I hope that makes sense. It's probably getting a little bit complicated. Now, what controls the output voltage of the alternator is two things. That's the speed of rotation and the current that you pull through the rotor. Now, what I'm planning on doing, so I've got a voltage regulator that fits like an old Chrysler back in the 80s, maybe the 70s, I'm not sure. And an alternator that's a Nipendenso, I can't say that very well, alternator like it came on a Dodge with an external regulator. And the way the regulator that I bought works, it's got a sensor wire that reads back to the post, to the voltage. It's just used as a sensor. And it's got a ground wire that goes back to the negative side of the rotor, or through the brushes and some terminals and whatever, but ultimately the rotor. And so how a Dodge worked is it had full power that went to the positive side of the rotor, and then the negative side goes to the regulator. So when it needs a lot of charging, the regulator basically shorts itself to ground and pulls high current through the rotor. As the battery voltage comes up, as you need less current, the regulator actually pulse width modulates, meaning it turns on and off at a very high rate of speed, and it stays off most of the time so that the current to the rotor is lower. I hope this makes sense. Now, what I'm going to do, my plan is I'm going to power the rotor in this thing, which is only rated for 12 volts or 13 or whatever, with a 24 volt battery bank. So as soon as you crank the engine up, it's going to have full voltage to the rotor and the alternator, and then it's going to be controlled, the voltage is going to be controlled by the negative side of the regulator. And what I'm going to do is I'm going to take a resistor, and I don't know exactly what ohm or what notch yet, but I'm going to take a resistor to put in line with the 24 volts so that the current through the rotor drops to the point that it has full voltage output when the generator is running at high speed, just barely. So basically the voltage regulator will stay shut all the time. It'll be putting out more or less maximum current, but the current through there will be regulated by that resistor. And then if it blows a fuse or one of the fans blows up or something, the regulator can turn the alternator back so it doesn't blow something up. But what I'm hoping to work here, if all this works out well, is using that same current through the rotor when the engine comes down to idle, without the voltage regulator being able to increase the current through the rotor, it'll actually put out less voltage. It may lower the voltage down to 9 or 10 volts or something like that. So when this generator sits here and idles, it won't be having to run the fans at full tilt. The other thing is when this thing starts and takes off, the big 24 volt alternator consumes about all the power that this little engine will put out at idle. It's 100 horsepower at 2800 RPMs, but it's probably only 25 or 30 horsepower or something like that down at idle. When it's cold in the oil stick, it's just right on the line. And by limiting the current through this fan alternator, will keep this thing from having a big inrush current. It won't pull 150 amps trying to zing the fans up and load the motor up. It'll sort of start them slower. It'll be less violent. Anyway, I know I rattle on a lot. I hope this makes a little bit of sense, but let's go out there and finish hooking this up. I got to get some fuses and a few things and see how it works. All right, so here we are. In hindsight, I feel like I kind of screwed you out of some video here. It sort of just got done. I kept doing one thing and I thought, well, this is too boring. They want to watch this, and that's too boring. But anyway, let me give you a recap of what I got going. By the way, I got 2 air conditioners right now running on the battery, so when we crank this up, we can kind of have a load on it. So the 2 fans that are in here, they're coming up here. The ground wires are coming back. They're grounded to this stud here, and then these fans are 2-speed, but if you hook both wires up, that's high speed. These connections here are both soldered. I just use a wire nut kind of as a cover, whatever, for it. I really like doing that on those bigger wires. Works good. Anyway, a couple of 40 amp maxi fuses is coming back to the positive stud. So anytime this generator generates power, the fans run. Now, what I did here, and I didn't think about this until kind of after I shot the last little intro part, I've actually got a 24 to 12 volt converter that's just right here, and what this does, it's rated for 10 amps, and it's what drives the the gauges and the little run light that's on the switch in the cab. Anyway, it's triggered off fuel pressure. Anyway, I just took 12 volts from this through a wire, and we ran 12 volts directly to this terminal. As I was explaining, the rotor power comes in right here. This is different than like a Delco 10 or 12 SI where the regulator's in the alternator. There's nothing in this to regulate it. It is just these are hooked to the brushes, to the slip rings, to the rotor. You can see the stator. Those are the stator windings, and then there's a diode pack in there somewhere. Power comes out here. It's very, very straightforward. Anyway, we got 12 volts that come to here, and so if we short this to ground, this alternator will put out full current, full voltage. It'll be enough to blow up whatever you're trying to run, or the alternator itself. And so what I've done here is I've got a 2 ohm resistor, and this 2 ohm resistor is in the ground wire. The ground wire comes down here into the resistor, out of the resistor into the voltage regulator, and this is a voltage regulator. And what this voltage regulator does is it shorts this wire to its case to ground. If the voltage on this wire, and this wire is nothing but a sensor, the sensor comes up to this terminal. If the voltage on this sensor is less than 14.5 volts, or whatever. Anyway, this 2 ohm resistor limits the field current, and I've got an effect kind of like what I wanted, except it's not quite as extreme. We'll put a voltmeter on this in just a minute. But basically, when it's running, or when it's idling, it comes down to about 13 volts, which slows the fans down a little bit. This takes the load off of them. I think they come down to about 30 amps total, something like that. And then when you kick it up to high speed, it goes to 14.2 or whatever, and the current goes up to about 45, 46 amps, something like that. Anyway, all this came out pretty good. This bracket kind of runs a little bit of an angle. Doesn't look that awesome, but it'll work. I welded a little piece of flat bar on here. Took some EPDM roof rubber and a hose clamp and clamped the wires to it so nothing's going to chafe or be able to get into the belt. Everything else is pretty straightforward. I may get a couple of zip ties here and tie this wire up. This positive wire is in this loom. It's just sort of got a loop right there. But let's start it up. I'll clamp you up here, take a voltmeter, and we'll get a reading of the output voltage of this, and then we'll take it up to high speed where you can see it. When I start this it should start, and then it takes it about a second or two to build fuel pressure. That's what kicks everything on. The fans will come on, and you should be able to hear the engine kind of load up. Here we go. Anyway, I got 2 air conditioners running aside off the batteries. Let's go in there and we can kind of see how much current it produces. Alright, so here's the current that we're pulling out of the batteries right now. They are currently at 93% state of charge. 121 amps. The front air conditioner gets kicked on. This may climb a few amps the next minute or so. But anyway, you got to remember that from the big alternator is what used to run the fans, and so the fans ate up a significant amount of generating power. At 12 volts you're pulling 40 some amps, and anyway that freed up a significant amount. 30 extra amps would be 600 free watts or something like that. Anyway, we'll bust this thing off, and it should come to life in just a second. It takes this thing a little while to catch up. Anyway, with 2 air conditioners running, I'm still actually putting power into the battery bank of 73 amps. So even with 2 air conditioners running, you'll only have to run that generator, you know, like on 2 hours and off 1. It's making more than enough power to run 2. So I got a few more things to show you here. Pardon this truck, it's a mess. But right there I added a gauge, and this is a gauge that's reading the battery voltage of the battery bank. And what this allows me to do when I'm going down the road, I can see if the batteries start to get low, I can start the generator. You know, there's a generator start button right there. And yeah, I don't know if you can see, but the battery voltage is actually climbing. It's up to 26 right there. So one more thing I want to show you here, and this is actually, I did this before I took the trip to Kansas, but I wanted to kind of save it for this video because it goes along with it. What I've done here is I've actually added a 110 amp 24 volt alternator, and this has got a cable that runs through the frame all the way back to the battery bank. What this allows me to do, and I'll say right now, this is a 110 amp alternator, but its actual output was more like 100 amps. But what this allows me to do is to charge the battery bank and run an air conditioner or whatever with the truck engine. Anyway, what this allowed me to do, and will allow me to do, is to charge the batteries and, you know, make electricity more or less going down the road without having to have the generator running. It'll also, if you're not in a high power situation like just running 1 air conditioner or something, it'll make sure when you arrive at your destination that your batteries are fully charged. Running 2 air conditioners, it won't quite keep up, but I'll get to that in a minute. But anyway, it was an honest 100 amp output, maybe 102, 103, something like that. It wasn't quite 110, but 100 amps at 28 volts is 2800 watts. Time you run it through the battery and the inverter and everything, you lose some efficiency, but it's still probably 2500 watts, maybe 2400, something like that. There's plenty of power to keep the air conditioner cold. You know, 1 air conditioner running, the refrigerator cold. You know, the hot water heater cycles. You know, it'll, you know, keep the water hot. It'll run the lights, run whatever. And in fact, actually, on my trip to Kansas, you know, it was 6 hours. I ran the front 2 air conditioners, and it was 100% steady charge when I left. When I got up there, I had about 60% charge, something like that, 55, I think maybe. And actually we're able to run the air conditioners after I arrived for a couple of hours till we got a plug rigged up where we could plug this thing in. But anyway, that voltmeter will kind of let me see where we're at, and you know, if we're going down the road with 2 or 3 air conditioners running, the inverter will run all 3 air conditioners and lights in the refrigerator, but if the water heater or something comes on, it'll go into overload. But if you're running 2 or 3 air conditioners, you know, that alternator will take up and make most of the power that you need. And if your battery bank starts getting kind of low, you know, if you see the voltage down 24 volts, you just reach over there and hit the gen start button and let your generator idle for an hour or so and bring that state of charge back up. And like I said, one of the neat things about it is if you're in most places where it's not 110 degrees like it is here today, and you just kind of have 1 air conditioner coming on, the bedroom coming on, you know, whatever, it'll keep the batteries at 100% steady charge, so they'll be charged whenever you arrive at your destination. Anyway, you know, I hope y'all enjoy this. I know this kind of gets more technical, and it's not real bells and whistles and fun. This is the kind of videos I like to make, and the kind that I like to watch. But nonetheless, I feel like I kind of screwed you on some of the bracket making on the generator, but I guess you get what you get. Anyway, that's about the size of it. I appreciate you watching. I plan on doing, I don't know exactly when, but I'd like to do a fuel efficiency test on it in Detroit. I really don't know. I think that it's going to be pretty efficient. I think it's going to surprise a lot of people, but I could be very, very wrong, and I don't know. Anyway, I'd like to get me a graduated gallon or a couple gallon jug and run some fuel lines in it, and run it under some different loads for a couple hours, or, you know, whatever, half hour per segment. I may try to do that next week. I don't know. Got to finish the cabinets up. I got some stuff to do. This is Friday the 13th. Tomorrow the video will come out, and I got this weekend without much lined up to do. I'm going to try to knock a bunch of stuff out, and maybe get a couple RV videos out. Plan on going on a trip. I think I'll go to Corpus. Not exactly sure, but keep you updated. probably not going to do a lot of in-depth videos about our actual vacations, but I will keep you updated about where we're going. You know, I go on vacation. I like doing the camera kind of when I'm by myself, you know, sort of in my element. But you sort of get out in public and walk around the camera and kind of look like a retard even more than I normally do. And so anyway, we'll see how all it goes. But anyway, keep you up to date. Like, share, subscribe, all the good things, and we'll catch you on whatever's next.